Hey everyone, so in this video we are going to be continuing with compound probability, which again is the likelihood that two independent events will happen. So yesterday we spent our lesson learning about how to list the sample space of compound probability with a tree diagram, right? Which helped us say, well, if we have these two events happening, what are all of the possible outcomes that we could have, right? Or our sample space. And we could use that as a visual to help us figure out the probability of a certain outcome happening. But what we're going to do today in these notes is learn how to do this without using a tree diagram. That's a fine method, and it's good to use, but here we're going to kind of learn how to use the way of calculating it without a tree diagram. So we're going to jump in with problem 1. So it says a fair six-sided die is rolled twice. What is the theoretical probability that the first number comes up as odd and the second number comes up as even? So what we're going to do is think about these two probabilities separately. So what is the probability that the first number comes up as odd? Well, on a die, right, 3 out of the 6 sides are going to be odds. And just to make our lives a little easier, we're going to simplify that to 1/2. So the probability that we get an odd will be 1/2. And then second, what is the probability that our next roll comes up as an even number? Well, it's very similar, right? Even numbers are also 1/2 of the die. So we're going to use those two. And the only step that we need to do in order to get our final answer, the probability that both of those events happen, right? First one being odd and second one being even, we just take the two separate probabilities and we're going to multiply them. So if we take 1/2 times 1/2, right? We practiced multiplying fractions again recently. That's going to give us a probability of 1/4. Right? So the chance that we first roll an odd and then we roll an even the second time, that's going to be 1/4. Right? So to wrap it up, all we do, we take the two separate probabilities and you multiply them to get our final answer. Okay, so we are going to scroll, or we're going to go down to problem 2, look at another example, and then we're going to check for problem 3. It is a coin example, which is like what we did yesterday. So we'll be able to compare it to our tree diagram. Okay, so problem 2. In bag A, you have the numbers 1 through 8, and in bag B, 1 through 4. So if you pick one number from each bag, what is the probability that you first pick out a 1 from bag A, and then an even number, any even number from bag B? So let's think about it. Out of the 8 numbers in bag A, the number 1 is only one of them. So the chance that we would get a 1 is 1/8. Okay? And then out of bag B, right, 1 through 4, 2 out of those 4 options would be evens. And we can just simplify that again to 1/2. Okay, so we have 1/2 and then 1/8. And like we did in our last example, all we have to do to get our compound probability is take the two separate probabilities and multiply them together. So 1/8 times 1/2. If we do that, we should get a compound probability of 1/16, right? Which is the chance that both of those events would happen in that order, in that way. So 1/16. Okay, we are going to finally go to problem 3. And it says a fair coin is tossed 3 times. What is the probability that the coin does not land on heads in any of the 3 tosses? Okay, so let's think about this, right? The probability that a coin, if you flip it, does not land on heads, right? Or in other words, what is the probability that it does land on tails, right? Hopefully you're agreeing it's 1/2, right? Because one of the sides is not heads out of the 2 total sides. Okay, and if we're flipping the coin 3 times, we just have to take our 1/2 and multiply it 3 times. Okay, so 1/2 times 1/2 times 1/2. The 1 will stay the same. 2 times 2 times 2 will give us a denominator of 8. So the chance that in 3 rolls we will not get a single heads would be 1/8. Right? In other words, we're looking for the event to happen that it would be tails, tails, and tails. So let's go back. We're going to flip back to our tree diagram from yesterday. Hopefully you remember seeing this, where we made 3 separate flips, right, and listed our outcomes, right? There were 8 total outcomes, which makes sense because in our fraction that we just calculated for today's notes, right, you just got a denominator of 8, and only one of those 8 all the way at the bottom was 3 tails. So that shows us that we calculated that correctly, right? 1 out of 8 of the outcomes was tails, tails, tails. So you can see how it's quicker to just do it by calculating like we were practicing today, but you can always go back to a tree diagram like this to help you get the answer. All right, so we're going to review our final question on today's notes, which is a U-try. So what we're going to do as a class, I'm going to pause our video. We are going to have you see about trying this one, and then in a couple minutes we'll come back on, we'll check it, and that'll be our notes for the day. So take a look over the U-try, see what you could come up with, and we will check in a few minutes. All right, so let's take a minute here to check our U-try. So they say a vending machine has 5 colors of gumballs and an equal chance of dispensing each one. A second machine has 2, perhaps 4 different animal-shaped rubber bands and an equal chance of dispensing each one. So if you buy 1 item from each machine, what is the probability of getting a yellow gumball? So let's go back. So we need to find the chance of getting a yellow out of all the gumballs. Well, 1 of the colors was yellow out of 5 total colors. So that probability would be 1/5. And then second, getting a lion band, right? Well, there were 4 types of animals. 1 of them was a lion band. So that would be 1/4. And like we've been doing in the rest of the video, as soon as you have both of your probabilities, to get your compound probability, you just take the 2 and multiply them together. So 1/5 times 1/4 will be 1/20th. Right? The chance that you would first get a yellow gumball and then get a lion band from the second vending machine.